So once again, thank you for joining us for Transforming with DevSecOps today. I have my very good friend Maria Pronin with me from Microsoft. Maria, would you like to please introduce yourself?
Yeah. Hi. Hi, everyone. My name is Maria Pronin, and I'm a cloud solution architect with Microsoft. I've been with Microsoft for about 2.5 years. And prior to that, I was for about 8 years with IBM, also in a cloud team.
Absolutely. So very knowledgeable in DevOps and cloud space from that point of view. And my name is Gunjan Syal. I'll be your host today. I'm a transformation executive at Emerald Technology Grouping. I offer transformation services at a strategy, governance, and planning level to clients in North America. So, as we said earlier, today's focus is DevSecOps. But Maria, our conversation actually began back in April, I think, when you and I had recorded a video talking about DevOps building blocks.
Yeah, let me recap a little bit so we are all on the same page about the building blocks of DevOps and key parts so we understand. Basically, DevOps uh, building blocks contain continuous integration, which means that developer team will use the source control to integrate even minor changes into one centralized place. So basically, even minimal changes get into one place, and this will help uh, change management
Mhm.
and uh, basically management of the code itself. The
Right.
next, once once the team adopted continuous integration, the next block would be a continuous delivery, which basically includes taking the new changes and uh, building them and running the automated tests, making sure that no new bugs introduced, and again for consistency and making sure that the least new bugs are introduced in the latest code. And on top of that, when we talk about cloud deployments, we should mention infrastructure as a code. So
Mhm.
basically, to keep your cloud deployment consistent and repeatable and fully traceable, you need to make sure that not only your code that runs in cloud consistent, but also the infrastructure that it lives on. So that's why the infrastructure as a code as a key component of the entire DevOps practice. And finally, continuous deployment that will take continuous integration and continuous delivery and automate it and deploy it. So basically, as soon as developer writes a code, you can um, make sure that it is tested, built, and deployed in cloud. So basically, this is the idea: streamlining the
Right.
changes, testing it, building it, and deploying it on consistent infrastructure in cloud. And on the bottom, the last piece that goes across all the above pieces is continuous learning, changing, and monitoring of what we are doing. So basically, this is in 2 minutes what we covered last time back in April.
Yeah,
So
and there's a full 20-minute video along with a blog post, Maria, that you had written, right?
yep,
I've placed a link to that at the bottom here. And what I'll do is when we publish these slides, I'll make sure that the link is available with that after the session as well.
perfect.
Wonderful. So then, building upon that, Maria, we've been seeing a lot of security threats from a cybersecurity point of view, and in general from a data leaks perspective as well. So some of the examples that come to mind were Garmin had a big data breach, a ransomware attack, in fact, that shut down all of their services for a better part of a week, which is kind of unheard of these days, right? Before pandemic, I would say. I'm one of their customers, and I definitely noticed it. If I went on a run and I couldn't access my data on their platform to see what the trends were, that impacted me directly. GoDaddy and some of the other websites were impacted as well. Even CRA, right? Canada Revenue Agency was impacted. So from that perspective, DevOps conversation then shifts a little bit to DevSecOps, right?
Yeah. So basically, on top what we already discussed back in April, let's bring security portion of it into the process that we discussed earlier. So basically, our goal is do everything that I mentioned earlier, plus making sure that the application and infrastructure and also networking where the application resides, that is fully secured. And as you can see on the graph on the slides, uh, the earlier in a software development life cycle you bring the security, the cheaper it will be to remediate.
Mm-hmm.
And here on this graph, you can definitely see the cost of remediation if the bridge is found. So basically, the sooner you find it, the cheaper it will be to fix. So that's the goal. That's why we introduce a security shifting left principle. And this
Right.
is what we are going to do discussing DevSecOps, where we will introduce security at early stages at the very beginning when we start planning and coding and even gathering requirements. So security can no longer be just a checklist of
Mm-hmm.
like gated approach or this check mark is met. Not anymore. So security has to be fully integrated into your code, into your build pipelines, everywhere across all the stages. Yeah.
Right. So I just want to take a moment, see if Sandra has any questions. Sandra, I'm not sure what industry or what line of work you're in, but please feel free to jump in. It's very much of a conversation, or use the chat feature if you prefer that. But let us know if there's any specific parts of the conversation you would like to jump into.
I think it's all clear until now. Thank you.
Okay,
Wonderful. Thanks,
perfect.
Sandra.
Thank you.
So just diving ahead.
Sure. So, and when we discuss now the blocks of application and to the very end when it's been deployed in cloud, the first place that we must secure is obviously the code.
Mhm.
And here are I outlined a few key tools that we have and best practices that any development team should consider before even getting into writing the code itself. So as we all know, the source code right now, nobody writes the source code from scratch, everything in-house. As the stats show, as I outlined here, that the new code takes about just 10% of the entire code base. Um, Everything else, developers use existing libraries, internal existing libraries, as well as open source is widely used more and more nowadays.
Mhm.
So that's why the breach can happen anywhere at any layer, and libraries use other libraries, so it's recursive. So that needs and person can introduce the breach security breach into the source code without even knowing it.
Right.
So that's why it is very important to scan your own code, as well as all the dependencies all the libraries that are used. And there are few tools that are available to uh, various software available for dev teams for scanning for known vulnerabilities
Mhm.
and such. For example, I know that GitHub, for example, offers the dependency scan as well. I'm sure other source code uh, providers.
So Maria, a
Uh,
quick question for you here.
yeah.
So you mentioned a lot of great tools, right? Like GitHub. For an organization, when they're starting to look at it, let's say a medium to large type of an organization, right? One of the things can be IT isn't always a centralized team, right? There could be different teams that have IT embedded in them. So if you're trying to create DevOps standards, how would you begin that discussion? Would you let these teams kind of do their own thing, or would you rather, bring them
So it
together?
all depends. So basically, if you take a GitHub example,
Hmm.
it's basically just the matter of enabling and scheduling those tools that are already available to you. So all
Right.
you go, you just go into your GitHub and you configure your repositories to go through um, security scans, through dependency scans. And it's basically almost one-time process. When you set up your project, you just go, you configure it, you just need to know of those features,
Right.
and you have to understand that it's very much needed.
So that's at the developer level, right? So when you're
Yeah, this
setting
is like,
standards,
yeah, this is right now we are talking about how you secure your code
right?
uh,
So
at the
these
very
are
beginning. Yeah,
right. So these are guidelines that the company would have to create for their
yeah,
developers, right? So
yeah.
things to keep in mind. So as you said, then each developer follows the same guideline to ensure the code that they are writing and deploying is secure from the get-go.
But because we, as we discussed earlier, continuous integration
Hmm.
basically ensures that code resides in one place, like
Right.
let's say master branch, like we talked about branching policies in a previous
Right.
video. But anyways, there is a master branch which is supposed to be customer ready and deployable at any time. So you
Hmm.
do not put broken code into your master branch. And
Right.
on that master branch, you configure code scans, dependency scans, and all that stuff. It's basically configured inside GitHub, for example, or Azure
Hmm.
DevOps, all the repository, like all depends what tool you use. It's
Right.
basically your choice, but that master branch has to be scanned regularly, and those reports have to be addressed as soon as possible. So basically,
Right.
if any problem is found, it has to be addressed ASAP.
Right. So
So
that's where the process piece sort of comes in, right? So there's the
yes,
setup and the tools piece. And then
yeah.
there's the process with the review to make sure that the compliance for those processes is actually there.
Absolutely. So
Yeah.
basically, it's kind of one-time big chunk of work, and
Right.
then of course you can tune and adjust and make it better. But at least know about those key points that you have to scan your own code as
Right.
well as dependencies, and update your dependencies regularly. uh, Also make sure that developers are properly set up. Basically,
Mm-hmm.
all developer access is also properly addressed and set up. Of course, here are like three key points of doing this. Two-factor authentication,
Right.
role-based access, and single sign-on. These are just best practices known to most of us for a long time.
Yeah, absolutely. And Sandra, I just want to check in if you have any questions or thoughts on this.
It's not clear for me. What do you name secret scanning?
There is a, like, for example, I'll give you an example. For example, a developer, let's take an example. For example, I have a .NET application that has a web config, and usually inside the web config, the developer may put a connection string which contains a key that lets him his application connect to the database. And this is big no. Those things have to be stored in a key vault or somewhere elsewhere, not in a web config. So if, for example, unexperienced developer would check in such code with the connection string in plain text into the repository, the secret scanning would tell you, okay, this is, let's say, connection string to a SQL database. That's a vulnerability, a big red flag. Remove it, please. This
Right.
is what I'm
So like a
by secrets.
password or a
Yeah,
token or anything.
password. Like there are many known patterns what to scan for, and yeah, this is what secret scanning is.
Okay, it's a mean for patronizing developers.
Not patronizing, making sure they are not making their code insecure.
Okay.
It's helping them. Developers should know that they shouldn't put any password, secrets, connection string in plain text in their code. But you never know. Sometimes, for example, when you do your testing, oh, let me try if it works, and it works, and then you forget about it, and by accident you check it in. So
Yeah.
the secret scanning would help you, will remind you that to remove it and not have it in plain text in your source control.
Yeah, and I can give you an example of that, Sandra, if that would help. Last year, actually, I think it was around November timeframe, just after the fall timelines, when companies typically do their annual planning, there was a big news that Scotiabank had a breach. And I don't think it was even a breach. It was one of the developers had put something on their personal GitHub, a part of the code that may or may not have been in production, right? But that's beside the point. So to Maria's point, if you use bad practices, you would use it in your rough code, you would use it in production,
Yeah.
you'd use it everywhere, right? So this person had copied parts of code and just for transferring it somewhere, put it on their personal GitHub and not realizing that that was made public then.
Yeah.
So part of that code was the password or the secret, if you will, to a particular database. Now, who knows whether that database was accessed or not and how long that code sat there, right? So it's good to have, I think, Maria, on top of this, just good practices, even beyond the scanning, to make sure that developers in a company have some standards.
Yeah, just as I said, like those things can be done before
Hmm.
developer checks in the code, and also regularly on a master branch
Right.
or that repository. So
As
it
a
has
last
to,
sweep.
yeah. So basically, it has to. It's not just one time kind of scan. It has to be regular,
Right. Does that
and
help, Sandra?
sometimes, yeah.
It's clear, yes.
Sorry, go
Okay,
ahead, Maria. You were saying sometimes.
yeah, I was saying, like, for example, like also about dependency updates and dependency
Hmm.
flaws. Uh, they are discovered like every day.
Right.
If yesterday people didn't know, today they do. So what's gonna happen? Um, uh, the uh, um, the bad dependency must be upgraded and vulnerability resolved. But then it means everybody has to be notified that this dependency, this library is
Hmm.
problematic, and they need to upgrade the version. Yeah. If there are no more questions, I guess we can move
Move to the next
to,
one.
yeah. So, and now that we've pretty much agreed that the source code has to be secured, let's move to the next big piece where security is a huge issue, is the infrastructure on a cloud where your application is residing in production or non-production, doesn't matter. So basically, um, for me, infrastructure is a code as a code is a key component of making sure that security is met, because every time you deploy your application in production, you need to make sure that infrastructure that it lives on is consistent. For you, obviously, you would upgrade and deploy application much more often than you would redeploy your infrastructure, but still you need to make sure that both of them are always consistent, always you always know what state your infrastructure in, that if there is a problem, you can trace it back and pinpoint where the problem is. You
Mhm.
can resolve it and fix it and redeploy automatically, and you will know which new state it is in. So basically, that's why I put infrastructure as a code as a first important part of securing the infrastructure, and also uh, into your scripts. When you automate and make your infrastructure as a code, you can put all the security features as you like. Like, for example, uh, you can restrict some networking ports when you provisioning a VNet in cloud.
Mhm.
You can put all those security restrictions and requirements straight inside your ARM template or your script that's provisioning that VNet. So basically, once it is lots of work in the beginning, but once you have those templates or scripts, it's kind of one-time deal. You can, of course, upgrade and improve, but at least you know that there will not be some human error when
Right.
someone went to the portal, created some VNet and forgot to make it private or something like that.
Mhm.
So the security is basically introduced as code is written for, like, the scripting for provisioning the infrastructure. That's one thing. Obviously, versioning, because infrastructure as a code is treated as any other code. From the very first version of your script, you can see who made which changes when and why. So basically, full traceability, versioning of your infrastructure, just the same way as you would do to your source code.
Mhm.
Very important. Also, the next step would be uh, enforcing the policies. This is on a pipeline step. So we are done with the infrastructure as a code and repositories. Now we are deploying, we are running those scripts, and this is where, when pipelines come into play, they
Mhm.
basically execute those scripts and deploy that infrastructure into Azure. So make sure that you come up with set of policies that will ensure that uh, that no bad infrastructure is provisioned. For example, again, going back to VNet example, you can have a policy that you are not allowed to provision
Mhm.
the VNet without network security group enabled. For example, uh, like, there are many different security policies that you can enforce right before the script is being run and provisioned an infrastructure in a bad state.
Mhm.
So it will make sure that security is met there, and also monitoring along the way. Basically, if you link your monitoring tools again straight into your templates, into your scripts from the very beginning. As I said, you will have to invest lots of dev time in the beginning, but then in operations and production, it will be very standardized and much easier to manage and troubleshoot.
Right. So
Yeah.
Sandra, any thoughts or questions there?
No, not in this topic.
Yeah, so
Okay,
one
great.
question that I actually do have, Maria, for you. From a governance point of view, again, a similar question as I had on the previous one, right? These are also some key decisions that people would have to make. So let's say I'm creating my very first pipeline
Mhm.
versus I'm creating my second one. I think it's important to review that governance to make sure that I keep it up to date with lessons learned from before, right?
No, not really pipeline, but depending what you are provisioning,
Hmm.
because policies are more or less applicable to different resources. For
Okay.
example, one policy is applicable to app service, the next to VM, the next one to VNet, or stuff like that. So basically, you will need to enable your policies based on what you are provisioning.
But each time I deploy something new in that resource, it's good practice to come back and take a look whether those policies still meet my
depends
basic
depends
needs.
depends what you changed.
Right, right.
Like for example, when you create a resource, you have to think of what policies you want to enforce. You would go configure them inside your as an before gate in your
Hmm.
pipeline, like before condition. You would configure some policies, uh, and you, of course, you will have to go and revisit it, but for infrastructure it's not as often as you would
Hmm.
imagine. It's basically changes to infrastructures are done much more rarely than you would do for the
Right.
source code of your application.
That makes sense.
Yeah, I guess we can. mm,
Yeah. So the next one, securing application and infrastructure.
So basically here, let's assume that we already secured our pipelines, our infrastructure, we versioned all our code, we have everything in place. And now let's consider the scenario when we are already in production and what we should make sure to do. So basically, of course, it's probably very common best practices. Of course, as we discussed for developer users or operation engineer users, also the end users of your applications have to have a proper access control. And here things like, again, enable your multi-factor authentication, of course integrate with Active Directory, use role-based access based on what the
Hmm.
user needs are, and always exercise the principle of least privilege, which means do not give the user permissions more than he needs. This is what it means. So basically, least privilege is a must. So if someone only needs a read access to your data, don't give a write access just in case.
Hmm.
That's basically the idea. Of course, just as we discussed about key scanning and secret scanning inside your source code, uh, do make sure that all the secrets, certificates, connection strings, and all information like that is never stored inside your source code or anywhere in plain text. It has to go in vaults, and vault has applications have least privileged access to vaults. Um, and it's actually a good practice to segregate data access and admin access. Basically, the person who can create new secrets
Hmm.
may not uh, is completely different role than the person who reads it. For example, application that reads the secret does not have the right to manage that secret. So
Right.
difference
Because that
reading,
would be a conflict of interest otherwise. Yeah.
uh, yeah, it's basically separated. Separated, it'll be easier to manage. Like you
Hmm.
would have, for example, just a couple of people in the organization who would be able to manage secrets,
Hmm.
meaning create buy certificates, create records in your vault, and then everybody else would have the least read permissions just to access secrets that they need.
Right.
So yeah, over here also rotate your keys regularly. This is what comes to accessing that data, and this is applicable for human users and users, as well as service accounts, meaning the applications. So application should be given permissions just as if it was a user. Like
Hmm.
this is called service accounts or service principals. But access for different client applications has to be set up and designed and implemented using role-based access, just as if it was the human user. So as before, of course, we would want to monitor everything that happens in cloud. Uh, Sometimes just enabling monitoring is not useful, even though you have the telemetry, but you don't have useful alerts. Or sometimes the team would create too many alerts and they become
Hmm.
noisy and nobody pays attention to them. So basically designing what alerts are useful and how to handle them is another very important key, because when you alert on everything, eventually your support person will start like missing the important ones in hundreds and hundreds of useless ones.
Hmm.
Um, and also always make sure that you have action plan on how to resolve those alerts, and knowing about alerts is one thing, but to start working on resolving issues is the other thing. And another last uh, last part here, I wanted to say that always try to use security management solutions. Like various cloud providers have various offerings. For example, for Microsoft, it's Azure Security Center or Azure Sentinel.
Hmm.
It's basically a service that lets you, that scans regularly your entire Azure setup on a subscription or elsewhere, or resource group scope, where you can, it will give you potential problems or problems, and actually uh, gives you ways of resolving it. Like it's really up to you resolve it or not, but at least you will be flagged
Right.
and notified and given some directions on what the problem is and how to resolve it. And here in centralized policy management, also a very nice feature where all the policies that we discussed earlier can be managed in one place.
Wonderful. Sandra, any thoughts or questions on this one?
When you think of security assessment, you think about human activity or externalized one to a vendor like
Both.
Kaspersky bought. It's an hybrid.
Both. For example, it can let you know that from bad configurations, some ports open, some I don't know, potential code where your code is vulnerable for attacks like SQL ingestion and stuff like that, as well as things like I don't know, potential performance issues and stuff like that. Like it's a whole list of known standard
Hmm.
problems that you will be alerted on.
Okay.
Like basically, those systems are the centralized place of the common knowledge as of now. It will try to help you to at least resolve something that is known your human employees might have missed. And it's continuous. I think you can set it up, it runs overnight because it scans across everything, network, infrastructure, code, and everything, and you will be notified. And like different systems work differently.
Hmm.
So some are more sophisticated, some are less. Some of them even use machine learning uh, for diagnosing potential future problems and stuff like that.
Yes, but how much the companies currently invested and implemented the vendor solutions?
Mm-hmm,
Because I see a lot of very interesting products
Hmm.
mm-hmm.
around, but I ask myself how much companies until now were disposed to spend on them. How much is automized the implementation right now of
I
externalization
I
and automation? How much is
I
going?
can I can only say that about Microsoft products, and they are it's both Security Center and Sentinel. They are services, and I think they are charged per scan, and they have multiple tiers. So you can buy more sophisticated service or lesser sophisticated and pay less. And just because it's a Azure like cloud service,
Hmm.
you pay for the usage mostly.
So it's bundled in that way, right? That's how it gets charged.
Basically, for example, if you have one service, let's say application service in Azure, you can enable Security Center
Hmm.
on that application service, or you may not. It's really your choice. But if you do enable, it's like an addition, another service that helps you run your applications. So basically it's a service and you pay, like you don't really implement stuff. For example, for Security Center, you just enable it on a different other services that support that feature.
Hmm. So that's within the Azure infrastructure, right? So if I just quickly go back for a
Yeah,
second, the other thing I can address is, again, I'm not as tech savvy and as hands-on as Maria is, but one of the things that I've noticed is some companies, especially the larger ones, they may have complex enterprise architecture solutions, right? So maybe they have an Azure piece, but multi-cloud has also been picking up steam. So maybe they have AWS pieces, they may have SAP somewhere else, right? Everything is cloud these days. So when you plug it all together, it still has to make sense. And I think that's where DevSecOps to me gets really complex too. So the reason,
absolutely.
yeah, so the reason I came back to this slide, Maria, is for Sandra, because we kind of breezed by it. But if you're looking at, for example, the Conference Board of Canada, they published this blue chart that you see on the left, right? So what they're saying is these are some of the type of attacks that companies are now seeing more than before COVID, because everybody's working remotely, everybody's online all the time. Before, you could actually go into the office and possibly work in a sandbox, unplugged type of environment, right? If you know what I mean, maybe not an online environment. You really can't afford to do that anymore. So the type of solutions, the type of services you would look at holistically would also depend on the type of attacks you're expecting. But as Maria said, looking at some of the solutions that are already provided to you by the vendors, looking at what they cover off, because the other beauty of that is every time Azure keeps trends on what is happening in the market, what type of attacks are happening more often than others, they may make some out of the box features available that are not available now, right, Maria? So, as a product roadmap for Azure itself, from a security center point of view, maybe Azure will make those things available and you can leverage them in future. So, that's the beauty of using it out of the box.
Yeah, yeah, it's much better to use something out of the box, because in Microsoft, teams and teams of security experts are working on those
Hmm.
products. Like, I don't think any development small company will be able to have that resource to develop something as sophisticated and as
Right. Or trying to cobble it together with different vendor solutions, right? Because the beauty of companies, whether that's AWS or Microsoft or even Google, right, with their cloud offerings, they have the luxury to be able to see it across because they're the top three vendor for cloud solutions.
as well, Gonjan, to add to your point, is that the whole beauty of cloud.
Hmm.
So basically, dev companies can focus on their specific product
Hmm.
without dealing with infrastructure, with their
Right.
servers, with security, because they are buying those as a service from cloud provider.
Exactly.
This is the optimization. uh, I would even call it as like, I don't know, industrialization, like
Right.
back in England in 19th century. Like, when you divide and give people their specific roles that they are really good at,
Hmm.
instead of
Yeah.
doing everything from scratch.
Absolutely. Economies of scale come in, right? So that's
Absolutely, yes.
where you can focus on your core business, which
Absolutely,
may
yeah.
be to create certain application or to deploy that application. And you're outsourcing the management piece of it. So to Sandra's point, there's different solutions for different problems, but it should be looked at with the context in mind and definitely starting with whatever solutions you already have. What are they offering out of the box? And
Yeah.
then what are the gaps that are remaining? And then you look at the probability of those gaps causing issues. And I would say the probability of those gaps causing issue right now is high, as we saw from that other chart, right? With 72% of the companies being worried about breaches. So it'd be interesting to see how that continues to develop, how much it costs and how much companies are using it. The answer probably depends from company to company and industry to industry also. That's something interesting to look at, though, for sure.
There are definitely multiple products that you can look at,
Hmm.
and but this is the choice of the specific client.
Right.
Over here, we finally introduced all the components, and now we can take a look at this DevSec example end to end. Uh, I took this sample architecture from Microsoft website, and link is below.
Hmm.
But basically over here, what you can see on the very left, you have the developer user who would have access through Azure Active Directory with enabled multi-factor authentication, single sign-on enabled. He would be able, in this specific example, to log in into his um, GitHub repository, not repository, but into the GitHub probably enterprise,
Hmm.
to be able to handle uh, the source code, the pipelines, called actions in GitHub to mm, uh, with enabled GitHub security features that we just discussed, meaning code scans, secret scans, as well as um, scans for dependencies, like open source and stuff. Also here, I wanted to add that now you, in case someone in your team found a brand new vulnerability, you can report it to GitHub and they will register it and basically
Mhm.
spread across community. Uh, that new vulnerability in specific library was found, and it will become known to everybody. So you can do it through GitHub now. Uh, so basically, after the code gets into the source code in GitHub, and in this example, you can use Azure pipelines, for example, to basically take your scripts and deploy resources in Azure. In this specific case, they did not use ARM templates or CLI scripts to provision infrastructure, but rather, if you follow arrow number 7, they used Terraform. That is a third party product that enables to provision infrastructure across different clouds. So you can use Terraforms with
Mhm.
Azure, you can use Terraforms with Google or any other cloud provider. So basically, you can see in this diagram, we exercise infrastructure as a code using Terraform. Also, this is a containerized solution, and our containers go into container registry, and on that container registry we enforce the policy. So before any container gets into that registry, policy has to hold.
Right.
And after that, like when you use that image from the registry and you want to put it into your cluster, you will make sure that that image is fully secured according to your policy setup. Also here on this diagram, you can see that all of the secrets and connection strings and the certificates and everything are stored in Azure Key Vault. Basically, the cluster uh, nodes access all these secrets only from the Key Vault. Also on this diagram, we can see that Azure Monitor is also enabled, meaning that all the telemetry of what's going on with this application on this AKS, we have all the telemetry of what's going on, and obviously alerts are enabled, and it's easier to manage and see what's going on. And as well as we can see that green shield with the lock on it, uh, we can see that Azure Security Center is also enabled, meaning that regularly we get the scans and we are alerted on any known vulnerabilities and bad configurations and things that must be resolved ASAP. And those alerts have I think 3 different severity levels, like red, yellow, and I'm not sure, but basically you have critical things that you need to address now, and something that you may think of later.
Mhm.
And on the bottom here on this diagram, we can see the end user who is using the application that is sitting on Azure Kubernetes service, and he goes through application gateway securely to inside Azure AKS. And as we can see, the end user is also using Azure AB2C, and multi-factor authentication is also enabled. So don't look at this as a recipe for every solution. This is just an example that shows all the features that we discussed earlier, but it's a pretty good demonstration architecture that shows all the pieces that we discussed earlier.
Right. So Sandra, any thoughts or comments on this holistic example, the end-to-end example?
Sometimes people complain about the fact that they buy a product, but because of improper configuration, in reality they they don't obtain the protection or the outcome that they were expecting for. And how much with, for example, this kind of product, they are in some way forced, or they can make assignment on the default configuration from a good level of protection.
And I would like this architecture is just a sample architecture that is that was built of many moving pieces. And as you rightly said, that at every single piece of this architecture, misconfiguration can happen because this system is fairly complex architecture. Like, you can look at it as a reference, but you're absolutely right. At each single point, if you do not configure it properly, it will it will it may bring you security breach for sure.
Yeah,
That's
and that's
absolutely true.
where the governance comes in, right, Maria? So to track what needs to be in place versus what is optional in what situations and how to
Uh,
monitor that.
Basically, all the components that I listed above, they are they are not must have, but at least team must know that they exist and what dangers they are facing if they don't do that.
Right.
So basically the list like of previous 3 slides, the team must consider every single bullet point as something to consider at some point of time. Because at every point there is a potential security issue.
Right. So I think building upon this, Maria,